Hi everybody. I'm going to make a quick video here on circle graphs, also known as pie charts. And as we kind of begin our study of various kinds of graphs and charts, I just want to make mention that a circle graph is appropriate when there is no overlap of categories. In a class, for example, the total number of responses would be equal to the number of students in the class. So for example, in this particular class, I'm looking at grade distributions, who got A's, B's, C's, D's, or F's, and it's not possible that someone got both an A and a B. And so I know that if I total up this column, I would get the total number of students in the class. So that's what I mean by no overlap. It's that a person can't be counted twice. I need to know that when I total this column, it is going to give me the total number of students in the class. Something where that wouldn't be the case would be if I was asking students in my class, let's say again I had 32 students in my class, but I'm asking them what sports do they play. Some students are going to answer that they play more than one sport. And so my total number of responses is going to come up being more than the number of students I have in my class. So that's what I mean by overlap. It's that there's not a one-to-one, one answer per student response. And so that kind of information would not be appropriate for a circle graph. Something that we would do later would be called a bar graph. And that would certainly be appropriate data for that. So for a circle graph, you can't fall into more than one category, so that when we add them, we do get, in fact, the total number of students that's in the class. So we're going to have that column typically first. The first thing we're going to do is turn these into percents, percent of students in the class. And the way we do that is if there were 8 students that got A's and there's 32 people in the class, then we know that 8 out of 32 would be the fraction that is equivalent to the percent of students that got an A. So if I just do 8 divided by 32, I get 0.25. Which now we recognize that decimal as 25%. Okay, then we have 6 students out of the 32, which is approximately 19%. It's 0.01875. So let's just round to the nearest whole percent here. And 12 out of 32 is 0.375. So again, let's just round that to 38%. 4 out of 32 is going to be 0.125, and we'll call that 13%. And 2 out of 32 is 0.0625. Which is about 6%. And ideally, if I didn't have any rounding going on, these percents then would total 100%, or all 32 out of 32 of the students. So I might be off. It looks like I am. It looks like mine are totaling 101% by the time all rounding is said and done there. But again, the ideal would be that they would total 100%. So if you're getting 101, that's quite okay. Just make sure that your rounding is appropriate. Okay, so to the nearest whole percent is what we'll go with here. Now, Percents are great, to talk if 25% of the students got A's and 38% got C's, but circles, whereas we know that the entire circle would represent 100% of the circle, circles are actually broken up into degrees. And we would call each part of the circle in degrees a sector. And so the next task at hand is to determine what sector of the circle we should devote to each of these categories. So if the first sector was 25%, then 25% of 360 degrees, which would be of the full circle, is 90 degrees. And then 19% of the 360 is going to be about 68 degrees. 38% of the 360 is going to be about 137 degrees. 13% of the 360 degrees is 47%. I'm sorry, 47 degrees. And then finally 6% of 360 is going to be about 22 degrees. So again, because we have rounding involved, these may not total exactly 360 degrees, but again, the ideal, if there had been no rounding involved, would be 360 degrees. And that is our full circle. So I'm going to start with the center of the circle and just draw a segment to the outer edge of the circle. And for the category that represents the A, 8 students that got the A, it says that that's 90 degrees of the circle. And you all know what a right angle looks like. So we're just going to, if you have a protractor, you can break out your protractor, but I know many of you don't at home, so we're just going to do the best we can in comparing these things to a right angle. So this one, we got lucky, it is a right angle, 90 degrees. So you can just call this the A's. The next one is 68 degrees. So if I came down from here and came straight out like this, that would be another 90 degrees. So 68 might be something like this. Okay, those would be the B's. Next we have 137 degrees. Again, from this line, if I come out like this, that's 90. So 137 is quite a bit bigger than that. So I'm going to do something like this. And those will be the C's. And then 47 degrees and 22 degrees, that kind of almost splits what remains. Something like that. Those are the F's and those are the D's. Okay? So if you have a protractor, feel free to use it. And if you don't get too caught up in, everything has to be just perfect, but do, say, well, the corner of a sheet of paper is a 90-degree angle and I should be a little less than that or a little more than that, and divide things up the way I did here. So the most important thing is that you have your percents column and you have your degrees column, because if you're off here, obviously I know exactly what degrees you had intended for each of the categories. So I'm just going to go back here and I can put in that there were 8 A's, 6 B's, 12 C's, 4 D's, and 2 F's. And you might also have seen, circle graphs where instead of using the actual number of students, they put the percents in there. In other words, for the A's, it would say 25%. For the B's, it would say 19%, instead of those actual numbers. And that's handy because if, someone said that 25% of the students got A's in this class, maybe I had a class of 40 students and I want to know about how many of them I would expect to get A's. Well, this says 25% of them I can expect to get A's. So I would be looking in a class of 40 for around 10 A's. So having the percents in there is helpful. So every circle graph, whether your textbook problem says to or not, I want you to have a column for the percent if it's not already given in percent, and I want to have a column for the sector of the circle, and then of course divide up the circle the best you can relative to the degrees that you said for each of the categories. All right, that is a circle graph. Good luck, have fun, and I will talk to you soon. Bye.